Let's look at a couple other problems too and see how some of these tools that we've been developing can help us further along some of the problems we may encounter. I had the 10th root of x to the 5th. I'm being asked to reduce that or simplify it. I can't see it too well if I leave it in radical form, but maybe if I change it to exponent form, I may have better luck. Well, if I change it to exponent form, it becomes x to the 5/10. And that looks reducible. X to the 1/2. And x to the 1/2 doesn't look like I can reduce it any further. So maybe now it's the time to change it back to radical world. And so it becomes the square root of x. And actually remember this too. It's implied, it's right there, and it's x to the 1. So the 10th root of x to the 5th does reduces to the square root of x. But in order to find that out, I had to change it to exponent world, then do my work, then bounce it back to radical world. Let's do that with a couple other problems and see if that helps us or not. I had the cube root of 27a to the 15th. Well, yikes. All right, so let's change it to radical world, and the proper change over there becomes 27a to the 15th, everything to the 1/3. That 1/3 applies both to the base of a and to the base of 27. So I'm going to spread that out, so that becomes 27 to the 1/3, a to the 15th to the 1/3. 27 to the 1/3, I can't reduce that down, but I can change that back to radical world. So that becomes the cube root of 27. The a to the 15th to the 1/3. Remember how you multiply or how you deal with an exponent to an exponent? You multiply. So 15 times a third. That becomes 15 over 3 becomes a 5, a to the 5th. So now I have the cube root of 27, which is 3, a to the 5th. And that is reduced as far as I can go. If I want, I can bounce it back to radical world, but there's no exponents and there's no need to do that, so I'm going to leave it right there. Let's look at the next one. The 4th root of x to the 6th y squared. I just want to see if I can reduce it, see what happens. So that becomes x to the 6th y squared all to the 1/4. Looks like I do the same thing where this becomes x to the 6th to the 1/4 times y squared to the 1/4. Exponent to an exponent, that's x to the 6/4 times y to the 2/4. Reduce the exponents where appropriate, so x to the 3/2 times y to the 1/2. And now I'm down in radical form, right, or in exponent form. I can mess around with it a little bit more and bounce it back. So this becomes blah, 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 blah. This becomes the square root of x cubed times the square root of y. And since they're both square roots, I can multiply them in sides. And so that becomes the square root of x cubed y. Guys, that takes a little bit of practice. I had to kind of really think through on that one. I was going slow, making sure I didn't make any mistakes, and seeing kind of where I ended up with. And I won't be surprised if maybe I have to do it one more time just to really make sure I got a rhythm going. Square root of x times the cube root of x. We want to see if there's anything I can do with that. Well, you guys get the picture. Let's put it in radical world first. So that's x to the 1/2 times x to the 1/3. How do I multiply numbers with like basis, different exponents? I add the exponents, so it becomes x to the 1/2 plus 1/3 becomes x to the 1/6, 5/6, Willie. See, that's 3/6 plus 2/6, that becomes 5/6. So that's x to the 5/6, and then I can bounce it back to radical world, which is the 6th root of x to the 5th. So my task again was just to simplify them down if I can. I know it doesn't look much more simplified than where we started, but my goal is just to practice that I can do it, because there might be an opportunity down the road where I'll need to do that. And lastly, this last example in this section right here, the cube root of the square root of x. Yikes! What does that look like? Well, let's just take it one step at a time. And like usual, when there's something complicated, we work with the innermost part first. So I'm going to leave it as the cube root of x, but I'm going to make it x to the 1/2. Because the square root of x is the same thing as x to the 1/2. Now I'm going to write this as x to the 1/2 times 1/3. Remember what I did here is the rule is if I have m to the a over the n, that equals a to the m time, or m over the n there. Is that what I had going on here, folks? A to the m over n. Exponent to an exponent. Okay, I got back where I had that. This 1/2 right here, the cube root of x to the 1/2, I was going down the right way because I really have in there, I have a 1. So I take everything inside and raise it to the 1/3. So 1/2 to the 1/3 equals x to the 1/6. And boom. There, I'm done. Sorry if I did confuse you a little bit on that. As I was looking at the problem, because there's so many tools you have in your tool belt sometimes, you're trying to figure out which one works, which one doesn't work. And it just requires lots and lots of practice. You saw me pull something out, maybe it wasn't the right tool, I had to step back for a second, give it a second thought, and think about where I was going with that. And there's where I wound up, and I'm satisfied with it. I think I did a good job.